Okay, what's the answer for number 1? I'll pick on Meaty. Good. Okay, so remember we were looking at doing the opposite. So what you're looking at is a minus, so you should do a plus 5. Okay, then x equals -6. That's what I said. I can't believe you guys are doubting my abilities. Okay, this is divide by 3. So what's the opposite of divide? Bring it up in times 3. So x equals -21. Now this third one is, you guys often confuse 2 and 3. They're much different. The first thing you have to do with number 3 is get x out of the basement because it's scared of all the spiders. So instead of divide by x, you bring it up in times by x. So we get 3 equals 4x, and then you can divide by 4, x equals 3/4. Okay? You have to get x out of the basement first, folks. Okay. Number 4, 2 steps. So you want to look to add or subtract first, then divide. Okay? So add 12. Then you want to divide by 12, x equals 3. Any questions? Okay, for number 5, put all the constants on one side, all the x terms on the other. Okay? So do a couple lines of work, find your answer for 5. Number 6, multiply in first, then solve. You do the same thing for 7. Multiply in first, then solve. Give it a shot. Go. Oops. So let's go recap with 5 and 6. Let's move the 5x by minusing 5x. You always look in front to decide on what to do. So you're not looking back here between this 5x and the 7. You're looking in front. There's a positive sign that's not written. Then you subtract 5. So we're going to get 2x plus 5 equals -7. That sign must stay. Then minus 5, 2x equals -12, so x equals -6. Okay, you got to be careful with your signs. Know when you can change them and when you can't. Number 6, multiply in, 6x plus 12 equals -15. Minus 12. That would be -27. Is that right? Yep. So x equals -27/6. Put in lowest terms, divide them both by 3. -9/2. Final answer. Okay. Now, I could give you a fraction or a decimal, but I wouldn't give you both. And all of you guys are calculator junkies, so what am I probably going to give you? Fraction, right?
Decimal.
I just told you. Okay. Number 7, multiply in, and then it's just like number 5. For number 8, how do we get rid of these fractions? What will we multiply everything by? 10. So you have to multiply each term, and the 10 will cancel out. So we multiply by the number that cancels. 7 and 8, give it a shot. Go. Hands up if you got 11/8 for number 7. No? Did I screw up somewhere? Well, of course, because I was just checking to see if you're awake. Okay. 9/8, hands if you got that. All right. Good thing you guys caught that mistake. Okay. Next one, multiply by 10. Okay, so we're going to get 10 times x over 5 minus 10 times 3/2 equals 10 times 2/5 minus 10 times x over 2. Oh my goodness. cancels to 2, cancels to 5, cancels to 2, cancels to 5. 2x minus 15 equals 4 minus 5x. Okay. Then you're solving from there. So we get 7x minus 15 equals 4. 7x equals 11. Just checking to see if you're awake. X equals 19 over 7. I have no excuse. Okay.
I think it was just Sean's punch.
Yeah, it's Sean's cupcake. It's probably poisoned. Give me some kind of like dumb pill or something. Alright. Next one. Now this is a special case. This would totally work if you multiply this one by 6. Okay, totally would work. But remember, you got to put brackets around the top. Okay, so that's a very key point. You need brackets around there because of that extra long division line. Okay, so go ahead and multiply this whole thing by 6. Go. Ends up for number 9 if you got x equals negative 12. Okay, this is getting a harder one, right? So the last couple questions. Remember, the last couple questions, each section of the test will be some harder ones. Okay. Okay, next one, 4, 6, and 3. What did you multiply everything by? 12. And what do you have to remember about this 2x minus 3? It's in brackets. Okay. Go ahead, multiply everything by 12. Give it a shot. Okay. Number 10, 19 over 10. Okay. Hands up, you got it? All right. This is like the full meal deal. You won't see one harder than that. It's got everything. It's got your fractions. It's got you remembering to put brackets. And then you got to solve. Okay. Turn over. Okay. Less than. Greater than. These ones will be an open dot or an open circle when you graph them. These ones have the equal to part. Okay, I'm not going to write it all out. These ones will be a closed dot. Okay. Okay, so go ahead, answer 1 and 2 now. Victor?
B.
B is correct. Okay. For example, here's a 2. You could verify it. So, 2 less than or equal to 3? Yes. Don't use the boundary point. And the boundary point is 3. Don't use 3 because you won't know if your sign's in the right direction or if you shaded in the right direction. Okay, so that's why we don't use 3. Number 2. Taylor. C is correct. So don't use the boundary point, one of those. You want to pick a number from the side you shaded. What number are you going to pick? Akama! What up? Yeah! Better before you got here. Yes. Yes. Yeah, see you later then. Those Akamas. I don't know about them. Okay, 5. So is 5 greater than 4? Yes, it's a true statement. Okay. Good. So when you're doing these, you have to be careful when you solve, because on the last step, if you divide by a negative number, it's only division, not subtraction. If you divide by a negative, then the sign changes direction. Okay, I got a serious conversation for you guys here. So, soccer, didn't girls soccer beat Yale? Okay, just saying. Okay, we, yes, okay. So I just want to talk about number 3 real quickly before I get to do it. The reason why is because I had to say before, oh, multiply by 2 to get rid of the fraction. You totally could do that, and you get x minus 8, blah, 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 20. However, you don't really need to either. The reason why is because if you move 4 to the other side by adding, be quiet, all you do here at the last step is multiply by 2 to get rid of it, because it's divide by 2. So the opposite would be timesing by 2. Okay? So it's up to you on which method you want to take to solve it. Please solve number 3 and 4, and be careful with 4. Now remember, when you graph, I'll show you an example. If x is greater than Heppner, then you want to put Heppner right in the middle. Something that's greater would be over here, and something that's less than would be over here. Then, once you get it set up that Heppner's in the middle, Barker's greater, and Sean is less than, you then would go open circle, and since x is greater, it'd be shaded to Barker's side. Okay? So, you're in the boundary point, you're kind of in the middle. Okay? So that's just an idea of how to graph. What's in the middle, what's greater to the right, what's less than to the left. Please finish questions 3 and 4 now. Go. Is it 18? Oh, it's 20. You suck.
Yeah, I get it.
Okay, number 3. Shh. Close dot, shade to the left. You must have 27, 28, 29. Always put the smaller one to the right, just like every single number line you've seen since grade 4. And put the larger one on the right. Okay? You must set it up that way. It must be smaller on the left, larger on the right. Okay. I multiplied everything by 2. Okay, treat it just like an equal sign, Emma. Okay. This next one. Notice how the way I solved it. Shh. The way I solved it, I would get x is greater than -1. If you solved it x on the other side, then your sign wouldn't change. And then when we divided it, you get the exact same answer. This blue box answer and the red box answer are identical. The signs are both eating the x. Okay. The blue one on the left, I'm dealing with a positive x, so I don't need to change the sign. I change the sides. Okay. But over here on the right, I do need to switch the sign because I divide by -7. Graphing that is easy. -1 here. Be careful when you graph negative numbers. 0 is higher, -2 is smaller. Okay, so you make sure you know the difference. Open circle, shading to the right. Okay. You should have both the blue square and the red writing. You should have both down there because you need to know that those are both valid ways of solving. Because sometimes in your work you might be stuck on one way. Okay. Any questions?